So this is another example in determining the slope and deflection of the beam using moment area method. So for this particular problem, we need to determine the slope at point A and deflection at point C. So this point and at this point. The beam is composite, so na siya duha ka member from ABC and then connected by an internal hinge to another beam na CDEF. It has 3 external supports, so a hinge at A, a roller at D, and a roller at E. It has 2 concentrated loads, 180 kN at B and 67.5 kilonewtons at F. It has a given value for I 2080 times 10 to the 6 from A to C and 1040 times 10 to the 6 for C, D, E, F. Its value for E is 200 gigapascal. So its I is not constant for the whole length of the beam. And then, so first we need to determine the reactions at the support. So we have here RA or AY, we have DY and EY. We need this reaction so that we can easily sketch for the MEI diagram. So first is solve for AY. To solve for AY, we need to analyze and sketch the free body diagram from A to the internal hinge C, and then concentrated load of 180 at point B. So we have here AY with a distance of 3 meters from A to B and 3 meters from B to C. So to solve for AY, we need to sum up moment at point C equal to 0. Say assume clockwise positive, AY times 6 is equal to 180 times 3. So AY is equal to 180 times 3 divided by 6, 90 kilonewton. Or you can solve this by simply looking at the figure. So the figure has a concentrated load located at the midpoint of ABC. So AY is equal to CY, which is equal to 90. So AY and CY will divide the 180 kilonewton load. Okay, next we need to solve for DY and EY by analyzing the second member of the beam. So we have here CY, which is equal to 90 kilonewtons, 353. And then we have DY, EY, and then the given concentrated load of 67.5 kilonewtons. So C, D, E, F. Let's solve for EY first, summation of moment at T equal to 0. Say counterclockwise positive. So we have EY. This is 3 meters, 5 meters, and 3 meters. So EY times 5 is equal to 67.5 times 8 minus 90 times 3. EY is equal to 67.5 times 8 minus 90 times 3 divided by 5. EY is 54 kilonewtons. Then by summing up forces vertical equal to 0 or along y, dy is equal to 90 plus 67.5 minus 54. Dy therefore is equal to 67 103.5 kilonewton. So let's sketch the MEI diagram. Okay, so let's solve first the moment at B. Cut the beam, and then AY times 3 meters. So AY is 90 times 3, 270. So this is 270 over EI. And then, oh, wait. At C, we're solving for moment at B. But let's cut the beam here. Analyze this part of the beam. We have CY, which is 90. Point B, so we have moment at B is equal to 90 times 3. So the same value of 270. At C, if you want to know the moment at C, so moment at C is equal to AY times 6 minus 180 times 3. Or the value for M at C is 0. And the next is to solve for dy. So let's cut the beam at point D. Solve for MD. So MD. And then use this segment. Here we have 90 downward, or CY, which is 90. So summation of moment at D is 90 times 3, but downward. So we have 270 over EI. And then for the moment at point E, here, at this point, let's cut the beam at E. Solve for ME using the right segment. So moment ME is clockwise if the right segment is used for analysis. So it is equal to 67.5 times 3, which is equal to 202.5. So this point right here is 202.5. Okay, sulat na ako para malibog. So M at B is equal to 90 times 3, 270 kilonewton meter. M at D is equal to CY na 90 times 3, 270 And then M at E is equal to 67 times 3. 0.5 times 3. 202.5 kilonewton meter. Okay, so we now have a complete MEI diagram. But for easier analysis and para dili po maglibog, kaning value sa I, pwede nimo siya uniform all throughout the beam. Ang given is 2080. Tira, then C2F is 1040. So you can say that I sa C2F is equal to, or duha ka I sa C2F is equal to I from A to C. Or ICF is equal to IAC over 2. So, mapareha siya nga 1040 times 10 to the 6. So, kani siya, i-divide mo siya 2. Kani po si 270. Divide mo siya 2. So, instead nga 270 over EI, mahimo na siyang 135 over EI, where the value of I from A to B, pareha na siya diri nga I, pareha na siya diri nga I. So, kanilang part yung i-divide o 2. Bali, ang I sa member A, B, C. So, i-divide mo diri nga I is 1040 times 10 to the 6 millimeter to the 4. Okay, so ang next is, sketch na to ang iyahang elastic curve. Based on the figure and based on the given loading. So, ano siya? Gikan diri nga point sa iyang external nga support, padulong diri sa internal niya nga D. Ang loading niya is kanira yung gina-carry or gina-resist niya nga load. Tapos kani is gina-resist niya diri po sa F. So, kaning 180 will cause a positive deflection diri nga member. Dayon, due to the bending of the beam diri nga part, mubalik siya sa 0 kay basta ang elastic curve imo siya i-sketch, imo i-consider ang iyahang mga boundaries. So at A, wala siya deflection. So imo elastic curve diha gina siya 0. Dayon na din siya deflection or slope. Then ay din siya mobalik sa 0 because at point D na kay support nga mag-resist sa iyahang deflection. And then mo bend imong beam. And then mobalik siya sa 0 at E because of again kani nga support, kani nga EY. So wala siya deflection at E. Dayon ay din siya mo deflect downward due to the 67.5 nga load. So, kung i-sketch nito na siya, medyo lower. See, paano siya? And then, okay. So, say, muna siya yung elastic curve. So, this is the exaggerated deflection or sketch of the elastic curve. So, para makuha na to ang gipangay sa problem, yung naman sa problem is, unsa daw ang slope at A. So, dire. Slope dire. Deflection dire. So, una na to si slope at A. Para masolve na to si slope at A, say, mag-sketch daw og elastic curve at point A. Elastic curve. Tangent line from the elastic curve at point A. Moagi ra siya sa point A, ha. Hindi siya straight. So, muna siya ang tangent line at point A. And then, another tangent line dere nga moagi sa point D. Dili siya curve. siya. Project pa rin na to. Suppose. Okay, so this is the tangent line at point D. Wait, ito siya tayo ipaubos gamay. Para mas ma-extend na to ang tangent line sa D. Okay, magamit natin siya later. Okay. So, unsa na itong solve si theta A. Nara si theta A. At point A, so muna ang original niya position. Tapos, kani din siya iyahang angle. Theta A or slope. At dayon, at point D, wait lang. Para masolve na to si theta A, nara ang triangle nga to i-consider. Kana siya, padulong dira sa ubos. Kana siya ang triangle. So, para masolve na to si theta A, kailangan tag kaniya deflection, kaniya siya nga change sa deflection, kaniya pag siya. So, tulo ka values itong kailangan. Dayon, divided by kaniya base sa triangle, which is 6 meters. So, unsa man nga mga values? So, this is gikan diri sa original nga position at point C to the tangent line at D. Kani siya. Muna siya ang deflection sa wait lang. Hindi taman. Gikan sa C. Padulong dito sa elastic curve. Gikan sa C sa iyang original na position. Padulong dito sa pinakaubos. Sa elastic curve yun. Kaya muna siya ang gi-deflect sa C. Mapo na siya ipangayo sa problem. So, ang imuhang theta A is equal to delta C plus kaning sa ubos. Gikan diri sa C on the elastic curve to or with reference to tangent line A. This is the deflection of C relative to A. C on the elastic curve to the tangent line A. So, para ma-solve na to si theta A is equal to delta C plus delta CA over distance base sa triangle, which is 6 meters. So, muna siya ang solusyon ni theta A. Ang next nga gipangayo sa problem is si delta C. Kani, pila man siya. Si delta C, kung tanaw na to, pwede ito magamit ani. Kay triangle magyapon na siya. O kanira ang triangle. Kanina triangle magamit na to na siya. But, kanang triangle, kung dili na siya taman, na siya. Gikan diri nga point, padulong diri nga point, kana siya is deflection sa C on the elastic curve to the tangent line D. So, kana siya, kaning gamay, ito may color ani na maklaro. Kana siyang gamay, kana siya is equal to the deflection of C sa elastic curve to the tangent line D. Dayon nga angle kani nga angle from the original position of the beam padulong sa tangent line D, kana siya is theta D. Kani po siya diri sa taas, kani po siya is theta D. Okay, so unsaon pag-solve si delta C? Para makuha na to si delta C, kani atong gamiton si theta D. So, ang relationship, kani nga triangle, relationship between the deflection and the slope. Kani nga slope, kani nga deflection nga part, kani nga part, which is equal to delta C minus kining gamay. Muna siya nga part sa triangle. So we have theta D is equal to opposite, which is equal to delta C minus delta CD over 3. Dere dayon nato ma-solve si delta C, which is equal to 3 theta D plus delta CD. So ang kailangan nato i-solve kani CD dayon theta D. Pero si theta D, ito na ito pa-solve si theta D. Pwede siya nga, dali na ito, kato akong gingan ganina. Ang dili ka nga pika side. Kaya mas, dali na ito siya i-solve si theta D. Ang gamito na ito is kanina triangle. Ano siya? Base is 5, angle is theta D. Ang kanina height tayon, theta D. Kanina din siya nga height. Ito na siya ilahos diri. Kanina siya nga distance is the deflection of point E sa elastic curve padulong sa reference tangent nga tangent D at D. So this is E to tangent line D. Using this triangle, nadayon kay theta D, which is equal to delta ED over 5. So muna siya una nga i-solve para ma-solve ni mo ni si delta C. Dayon si theta A, para ma-solve mo siya, kailangan mo i-solve una ni. Okay, so i-solve na to una si theta D. Theta D is equal to delta ED over 5. Delta ED is equal to x bar integral of m over EI from E to D, or from D to E. D to E. So from the MEI diagram, D to E is kaning area. Kaning siyang area. Ito yung label ba? A, B. Dayon, kuhaon na tuunan yung distance. So, 270 minus 202.5. 67.5. Kani siya. Okay, so from D to E. So this is moment sa area under the MEI diagram about E. Kaya sa tuang gikuha, this is the deflection of point E to the reference tangent D. So may muna siyang area sa rectangle. Area sa rectangle is 202.5 over 5 over times 5. So 202.5 times 5 times its perpendicular distance nga 2.5 padulong sa point E. Dayon plus area sa triangle 1/2, base is 5, height is 67.5 over EI. Kani siya is over EI. Dayon the triangle, super magaling sa triangle. Dayon padulong sa E. So kani siya nga perpendicular distance 2/3 of 5. 2/3 of 5. So delta ED is equal to 202.5 times 5 times 2.5 plus 0.5, 5 times 67.5 times 10/3. The answer is 3093.75 over EI. Dayan theta D is equal to 3093 over 5 EI, or this is equal to 618.75 over EI, kilonewton meter squared. So nanatay value sa theta D, masolve na nato si delta C. Kailangan tag delta CD. Ahir na to siya mabutangan ng equation. C to D. C to D. C to D is kaning triangle. So delta CD is equal to integral m over EI dx x bar from C to D, 270. Base is 3. 1/2 270 over EI times 3 times yang moment arm should be measured padulong sa C, 2/3 of 3. 2/3 3. CD is equal to 0.5 times 270 times 3 times 2, 810 over EI, kilonewton meter cube. So ato din ni siyang i-substitute si theta D and delta CD diri nga equation para ma-solve na to si delta C. So delta C is equal to 3 theta D plus delta CD. 3 times theta D is 618.75 over EI plus 810, which is equal to 3 times 618.75, 810, 2666.75.25 over EI, kilonewton meter cube. So delta C therefore is equal to 2666 over E. Ang E is 200 gigapascal times 10 to the 6, tapos 1.04 exponent 6 divide 1, 2, 3 times 10 to the negative 3. Delta C is equal to 266.25 200 exponent 6 times 1.04 exponent negative 3 0.01282 meter, or this is equal to 12.82 millimeters downward. So we now have delta C. Ang last na ito nga i-solve is theta A. Si theta A is delta C plus delta CA over 6. So we need delta CA, delta C relative to tangent line A, x bar m over EI dx from A to C. From the figure, A to C is kanina triangle. This triangle. So 1/2, base is 6, height is 135 over EI, yung height. So this is equal to 1/2, base is 6, height is 135 over EI. Yung perpendicular distance kaya naman itong triangle A, C. So imo siyang i-rotate about point C. So kanina distance kato nga, which is 3. So this is equal to delta CA is equal to 0.5 times 6 times 135 times 3. 1215 kilonewton meter cube. Theta A is delta C. Pila man si delta C? 2666.25 plus CA nga 1215 all over 6 EI, or theta A is equal to plus 1215 divide 6, 646.64875 kilonewton meter squared. Theta A therefore is equal to 646.875 210 to the 6 1.04 10 to the negative 3, or theta A is equal to 646.875 200.6 1.04 negative 3 0.003 radians. Okay, so this is the slope at A and the deflection at C for this given beam.